Okay, we've got some problems that I asked you to do. And after doing the assignment on toolkit functions, I was a little surprised people didn't know to make a table and then make a graph that fits the table. Some people knew to make a table. And then estimated solutions is not something that I was intending to grade, just see if anybody knew how to do that, okay? Because I don't think OpenMath said much about that. I don't think it asked you to estimate any solutions. Okay, so this is for the function g of x. Now, usually OpenMath use numbers like between -3 and 3. I don't see when the functions are introduced where the graphs go much beyond that, but they might, okay? But I'm going to stick to -2 and 2. And I should have said that. I intended to say that and I didn't, so that's kind of my fault. Now, usually I'm going to use like -2, -1, -1/2, 0, 1/2, 1, and 2, and I didn't leave myself enough room. So let me see if I can get myself oriented here. I'm still right big enough that you can see it. Okay, so it's going to be 2, -2, -1, -0.5. We usually use 0 and 0.5, or actually I prefer the fractions 1/2, 1/2, 1, and 2. Okay. So when you make a table for one of these are kind of the default X values that you're going to use. And I'm pretty sure OpenMath uses those values, maybe a couple of others. It might include -3 and 3 in their videos and so forth, okay? Well, anyhow, the absolute value of -2 is 2. The absolute value of -1 is 1. It should be -1/2. Absolute value of -1/2 is 1/2. 0, 1/2, 1, 2. So that's a really easy table to make if you know what the absolute value is. Then you can make a graph. Okay, now I tend to make my graphs in Windows. Because if you look at a graph on a computer or on a calculator, and you'll have plenty of opportunity to do that, mostly in other courses, but also in this to the same extent, okay? You're looking at the graph in a window. And I see that my X values go from -2 to 2. So I'm going to label this vertical dotted line X equals -2. And I'm going to label this vertical dotted line X equals 2. My Y values go from 0 to 2. So I'm going to label this horizontal line Y equals 0. And this one Y equals 2. It's this line and this line. Then halfway between -2 and 2 is 0. Halfway between 0 and 2 is 1. Halfway between X equals -2 and X equals 0 is X equals -1. I'll label that down here. And then we have X equals 1/2 here. And X equals -1/2 here. Y values halfway between 0 and 2 is 1. Halfway between 0 and 1 is 1/2. Halfway between 1 and 2 is 1.5 or 3/2. But that doesn't appear on the table. So it's more or less optional to use it. And I'm going to go ahead and put it in here. Okay, now one of the reasons I like to label everything well outside the window is so that it doesn't interfere with what goes in the window. However, I didn't leave myself enough room over here. If we plot these points, -2, 2 is there. -1, 1. Here's where x equals -1 on this line. Here's where y equals 1. There's -1, 1. -1/2, 1/2. Well, here's x equals -1/2. Here's y equals 1/2. They meet at this point. We have the point 0, 0, which is down here. The point 1/2, 1/2. X equals 1/2 line is here. The y equals 1/2 line is here. 1, 1. The x equals 1 line. The y equals 1 line. And 2, 2. The x equals 2 line here, and the y equals 2 line here. And there are the points. And that's the absolute value function. Okay. Now, I often see, and I think I saw it once or twice here, where people only do this part of the absolute value function. It's important to have both parts. It's important to show for both negative and positive values as your homework asks you to do. Okay. So you make a table, you sketch your graph. Now, if you sketch your graph like this, -10 here and 10 here, and let's see, we got, well, let's see. This is a lot of extra trouble for no benefit. Your points would have ended up here, 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 and here, and then here, here, and here. And you would have had a graph that looks like this. And that's kind of what I usually saw. People are in the habit of drawing the scale before they decide what values they're going to use, okay? So I advocate you make the table before you draw the graph so that the graph will fit the table. And if you want the table to go from -10 to 10, well, you use numbers from -10 to 10 to make your table. And you don't do your Y scale until you know what your values are. Okay? Otherwise, you got all this blank space in the graph where you could have a graph that pretty well covers the window, right? Okay. Now we want to use the graphs to estimate G of 1.7. What does G of 1.7 mean? Well, G of 1.7, you've done the assignment function notation last week. It means you replace X here with 1.7, right? And the answer is going to be 1.7. But that's not how you estimate it. You know what the answer is going to be, but you're calculating it if you do that, okay? And of course, it's really easy to calculate it in this case. But in other cases, it's not going to be easy. So we want to see what it means to estimate. And to estimate, that just means, let's find 1.7. I need more room to write, and I don't want to go to a new board. So I'm going to erase this useless graph up here. Okay. G of 1.7 is a y value when x equals 1.7. Where does x equal 1.7? Well, here's x equals 1, and here's x equals 2. 1.7 is between 1 and 2. Halfway between 1 and 2 would be 1.5. You got to go a little bit closer to 0.2 to get 1.7. So that's about 70% of the way from here to here, maybe between 60 and 70%. So we do an estimate. And that vertical line meets the graph. What is that line? Well, y is 3/2 here. Now 3/2 is 1.5, as I hope you know, okay? So this is like the line y equals 1.5. So what's this line? It looks like about 1.6, doesn't it? It's pretty close to this line. It's between 1.6 and 1.7, but I'm going to say it's y equals 1.6. Well, that's an estimate. So I don't use an equal sign, actually. I make the equal sign a little bit wavy. You know, it's kind of like this. That means approximately equal to, okay? You only use an equal sign for an exact. And an estimate from a graph can never be considered exact. Okay, well, we know that G of 1.7, if you plug in 1.7 for X, you get absolute value of 1.7, which is 1.7, right? The 1.6 that we get from the graph is close, but it's not quite exact. That's because, you know, I said that line should have been a little further to the right. And maybe we would have gotten up to 1.7 if I'd have drawn it more accurately. But if you draw it reasonably carefully, you get a pretty good idea of what the value of y should be. Okay. Then the g of x function, we want the solution of g of x equals 0.6. Well, in order to do that, this is an equation. It has a solution x for y equals 0.6. Might be a better way of saying that, but what that means is y is going to be 0.6 because g of x is the y value. It says y equals g of x, right? So g of x equals 0.6 means y equals 0.6. Well, here's 1/2, which is 0.5. The line y equals 0.6 is right about here. Now, what's the x value where this line meets the graph? Where does the y equals 0.6 line meet the graph? Well, it meets the graph here. Of course, it also meets the graph here. Okay? Makes sense? So we want to know what the x coordinate is at each of these points. Well, it really looks like x equals 0.6 here. And we come over here. And we're close to the x equals -1/2 line, a little to the left. And it looks like x. I should have used an approximately equal sign. Is approximately negative. 0.6. Can you read that? Kind of small. It's pretty prominent color. Okay. I don't have enough room to write. Should have used a bigger board here. But the solutions are I'll say the solution set is negative 0.6, 0.6. Again, I'm cramped. So this 0.6 isn't written very big. I had to squeeze it in with the brace to miss the H. Okay, does that make sense though? That's something you want to digest. Here's a picture of an equation. Okay. Now I think there's a section on absolute values. Anybody gotten to absolute value in their pre-calculus course? Okay, it's about the fourth, maybe the fifth section, I think, in the text. And I might even be confusing that with a different text. Although the two texts I'm thinking about are very similar. So I'm going to just digress before we get on to our a to the x function. This over a little bit and put this back. Okay, here's the equation. G of x equals absolute value of x. Okay, this means, I'm sorry. I mean, that's a definition, but we've already got that. G of x equals 0.6. How do you solve this equation algebraically? Well, that means absolute value of x equals 0.6. Now, as we can see from the graph, there are two numbers, two values of x that make the absolute value equal to 0.6. If x is equal to 0.6, the absolute value is 0.6. If x is negative 0.6, the absolute value is still 0.6. So the way I write this, I split this into two equations. I put the word or between them. So this might not be exactly the way your instructor writes it if it's a different section, but it's equivalent. The point is, the thing we're trying to see here is, number one, from this graph, we see that there are two solutions. Because the line y equals 0.6 hits the graph in 2 points. From knowing what the absolute value means, the absolute value is 0.6 or negative 0.6 or plus 0.6. Doesn't depend on the graph, but the graph shows you that it's so. And one of the commonest mistakes I see is that people ignore this solution and just give me this. They just remove the absolute value signs and solve the equation. Okay? Please don't do that. It's going to cost you. Maybe not a whole lot. Depends on how important your instructor regards absolute value equations to be. But I think, for the most part, they get a good bit of respect. I'm going to lose my board there. No, I've got everything. Okay. So, and then we say the solution set consists of negative 0.6, 0.6. And just to illustrate a little further, to give you a little head start, because that's what we're all about here. What if you had absolute value of 2x minus 3 equals 7? Well, you got something inside the absolute value sign, happens to be 2x minus 3, could be anything. But if the thing inside the absolute value sign equals 7, I mean, if the absolute value of the thing inside there equals 7, then the thing inside there is either -7 or +7, right? So this equation splits into two equations, 2x minus 3 equals 7. And I like the word or, I put it in capital because there's logic involved here. It's not and, because it can't be both. And let's say I didn't put a negative on this 7. Okay. You see the negative sign? Yeah, I didn't write that very well. Let's do it. Okay. Now these are two equations that we can easily solve. So I'm just going to put dotted lines down here, or 3 dots, to indicate you fill in the blanks. You're going to add 3 to both sides, and you're going to divide both sides by 7, and you're going to get x equals 5, or x equals, this one's x equals 5, this one's x equals -2. Yeah, or x equals 5, right? Okay. So your solution set includes -2 and 5. In other words, x can be -2 or it can be 5. Okay, take that to heart, because this is really something you want to get straight now, because people tend to forget it. Okay. Okay. Now let's deal with our h of x function. So I'm going to pull this board way over here. Put this one over as far as I can. All right. H of x equals 1 over x squared. So we make a table. Unfortunately, I've got this so far over that I'm blocking the board on the camera. And for anybody that's sitting on the right side of the room, let me bring this over just a little more. It's not quite as bad. Okay, so you set up your table. I'm saying -2 to 2 works. You really want 1/2 in there for most functions. Okay. So what do you get? If x is -2, what's h of x? Well, you're going to get 1 over -2 squared. H of -2 is 1 over -2 squared. That's what the rule for the function tells you to do, which is 1/4, because -2 times -2 is 4, right? Okay. And then 1 over -1 squared. Well, -1 squared is 1, and 1 divided by 1 is 1. Now 1 over -1/2 squared, and I kind of had to use a slant line for the fraction there because I didn't give myself enough room. Okay. But let's do that calculation to make sure we understand, or at least to show you that you need to do a little more work with fractions if that's the case. Okay, 1 over -1/2 squared, that's 1 over, let's be careful and write out -1/2 times -1/2. That's 1 over 1/4. What is 1 over 1/4? That means one divided by 1/4, doesn't it? And when you divide by a fraction, what do? You multiply by the reciprocal. So that equals 1 times 4 over 1, which equals 4. Now you have to understand that arithmetic. If you rely on a calculator to do that calculation for you, you don't understand very much about the function. Okay? And pre-calculus is all about understanding functions. So this equals 4. Okay, 0. Well, one over 0 is not defined. I can count to 1 by 1/4. I've got 1/4 and another 1/4, I've got a half, and then I've got 3/4, and then I've got 1. It takes 4 1/4 to make 1. How many zeros does it take to make 1? You can't make 1 out of zeros. No matter how many zeros you got 0. Okay? Take 100 million people, each with no money in their pocket. They've got no money in their pockets. Okay? No number of people with no money in their pocket can equal a group with $1 in their total pockets. Okay? Actually, that's the best way to say that, but you can't count to 1 by zeros. Okay. Now you got 1 over 1/2 squared. Well, that's just like this, except you don't have the negative signs. And since you're squaring the -1/2, the negative sign doesn't matter. And then for 1, you get 1 over 1 equals 1. For 2, you get 1, well, 1 over 1 squared. 1 over 2 squared is 1/4. Okay, you make a table. Now in my class, we first learned to construct these things by pictures. Okay? But this connects the pictures with the table. This is one I'll show you during my class, how to construct. You just use a type 2 grid. And it comes right out. The rule is very similar to the one for squaring. And we'll see it soon, but it won't give you any trouble if you know the rules for the functions we've been talking about. Okay, now I've taken the board away, but you want to estimate. Well, first, you want to do the graph. Okay, so here's the graph. Our numbers go from -2 to 2 here. And our numbers go up to 4. They don't quite go down to 0, they go down to 1/4, but we usually want to have the 0 point in a graph, not always. So we're going to have, oh God, I don't have enough room. What are we going to do about that? Okay, I'm going to pull this way over here. And I'm going to work right here. So I want to have plenty of room to do this graph. Okay, make a fairly big graph. X goes from -2 to 2 as before. So here's x equal to -2 Over here is x equals 2. In the middle, between -2 and 2, of course, we have x equals 0. And x equals -1, halfway between -2 and 0. And x equals 1, halfway between 0 and 2. If you sketch the graph like this, and I'm not saying you should, but one way to do it, you take this interval and cut it in half. You pretty much see where half is. Okay. Then you cut each of these intervals in half, you can pretty much see where half is. I'm a little too far to the left with this one, but it's reasonably close. That is in many ways preferable to try to draw an axis like this and make a bunch of equally spaced marks. They automatically come out pretty equally spaced if you do this. And people make a lot of mistakes when they do a graph like this, although I haven't seen anybody in here make that mistake. So there's a reason I do the graphs like this. One reason is my labeling ends up somewhat away from the window, as I said before. So there are my lines, same as the vertical lines I had before. There's y equals 4. I say it's a good idea to go halfway between y equals 0 and y equals 4. Draw a line there. That's your y equals 2 line. Then halfway from 0 to 2 is your y equals 1 line. But you see, we're going to need a y equals 1/4 line, aren't we? Okay. Now we've got the y equals 4 line, so we can plot this point and this point. We've got the y equals 1 line now, so we can plot these 2 points. We don't have a point for x equals 0, so we don't have to worry about it. But we've got to have y equals 1/4. So where's y equals 1/4? Well, that's halfway between y equals, well, go halfway from y equals 0 to y equals 1. Then we get y equals 1/2. And halfway from 0 to 1/2 is a line that we really want. I have to extend it all the way out here so I have enough room to label it. Okay, make sure we're on the screen. I'm not sure we got that last point. Let's see. That last label. Still not there. I'm going to have to break down and move the camera. And of course, camera's not real receptive to the idea of moving, but there it is. Okay. Now we can draw the graph. -2, 1/4. Here's x equals -2. And we want y to equal 1/4. That's going to be this line. So it's going to be where the -2 line meets the y equals 1/4 line. Okay. Then -1, 1. Well, here's x equals -1, and here's y equals 1. Then -1/2, 4. Okay, x equals -1/2 here, y equals 4 here. So there's our point. Now, if you're in my class, I'll just mention that this happens to be actually a type 1 grid horizontally, but vertically it's like a type 2 grid. If you're not in my class, you don't need to know that terminology. It's not a universal terminology. But the rule, if we draw this grid, is over 1 up 2, over 1 up 2. And now we're at the end of the window and we don't go any further. So our graph Going to look something like that on the left-hand side. Now you notice every time we went twice as close to zero, because we go from -2 to -1, we're going half the distance from -1 to 0, right? So when we went half the distance, we went up 4 times as high because we went from 1/4 to 1. Okay. Now from here we go half the distance to 0. That's from -1 to -1/2. And we go up 4 times as high. We go from y = 1 to y = 4. Okay. Now we can graph the points on the other side. I could start up here at x = 1/2, y = 4, and do x = 1, y = 1, and x = 2, y = 1/4. I almost did something really dumb there. It's not really dumb because I've seen a lot of people do it. It's dumb if I do it. And we connect these points. And that should be very familiar to you. Because that graph is part of what you studied. Okay. A lot of people drew a graph that looked like that. So I know you weren't working in a vacuum, but yeah, we got to do the details. Okay. Now, a lot of times, and there's a point to it, we could also include x = 3. Okay. And if we go over to x = 3, y = 1/9, which is less than half of 1/4. So this graph starts flattening out and almost gets flat, keeps moving closer and closer to y = 0, but never gets there. Okay. On this side, it keeps moving closer and closer to x = 0, but it never gets there. We could go twice as close to 0 here. We'd have to go twice as high. So we'd have to go from here up to here. So we'd have a point at this x coordinate, we'd be way up here. And the next would be twice that high. Get out of control real fast. After 30 steps, we'd be way out of the Earth's atmosphere. Maybe a good way toward the moon. You don't want to draw that graph. Okay, at least not on this scale. All right. I will mention, let's take the right-hand side of the graph. This is how gravity falls off as you move away from the Earth. And there are more everyday applications. It's kind of neat to understand that. All right, now what I ask you to do is make some estimates. Estimate h of 0.7. Okay, so h of 0.7 equals what? Or is x = 0.7? Because you need x = 0.7, right? So this expression is actually saying, since y = h of x, x is 0.7 because that's what we put in for x. And this is asking, what is the value of y? Well, x = 0.7. Here's x = 0. Here's x = 1. 7/10 of the way is about here. And this isn't a particularly great graph, but we'll take what we get. Okay, so where does the yellow line hit the graph? Well, it hits it about here, doesn't it? Make sense? And what's the y value here? Well, it's approximately 1.6. Okay. And that's from the graph. Now, it's actually closer to 2. You see that line's so steep right here, and my lines aren't all that good. That's a hard estimate to get right. It's hard to get the right steepness in the graph. And I certainly didn't do a great job of it. So sometimes, especially when the graph is near vertical, you're not going to be expect to be able to make a really good estimate. But you can always calculate it. And that actually comes out like 0.202. I'm sorry, 0.204. And then some more decimals. Okay, now. H of X equals, what was it? 3.4. Okay. So that tells us that Y is 3.4. Well, we don't have the scale marked all the way from 2 to 3, but it's easy to do. From 2 to 4. Halfway between 2 and 4, we make a line. That's at Y equals 3. Now, where's 3.4? Well, it's between 3 and 4, a little closer to 3. Then I could make a line halfway between and so forth. But I'm just going to say, okay, well, here's a line a little less than halfway between 3 and 4. And we're going to say that this is a line Y equals 3.4. And we're going to try to estimate X. Well, that line crosses the graph here, which is pretty much the way I drew it, right on the line X equals 1/2. Okay. X is approximately 1/2. Now, really, X is 1 over 3.7. 1 over 3.4 squared, I'm sorry. And the square root of 3.4 is about 1.8. So actually, your solution to this equation would be about 1.8. So that's not 1.8, reciprocal of the square. So it's reciprocal of 1.8, which is like 1.1. Or sorry, 0.4. 0.45 or something like that. Okay, pretty close to 1/2, but not exactly. Okay, well, the point is to solve the equation, that means Y equals 3.4. So we draw the line Y equals 3.4 and figure out what the X coordinate is. If we know the X coordinate, we draw the line for X and see where it hits the graph and see what Y is. So it's just a matter of interpreting what these questions mean. That make sense? Hope so. Now let's see if you got audio and all this. I'm pretty confident. Okay, in Tuesday's class, I believe, or maybe it was Thursday's class, I talked about composite functions. I'm going to just talk about that a little bit right now, because that's going to be one of your assignments. But it's not going to be due until Thursday. Okay, the one assignment you have between now and Thursday. Uh-oh. I'm sorry. I'm looking at the schedule. I'm losing track of what day it is. Okay, you do have the assignment on composite functions. It'll be due next time. And it's actually, here it says it's due tonight. But there are too many assignments between now and Monday. So I'm gonna make some changes here. And I'll tell you what they are. And I hope I can still stay ahead of the other class. Almost nobody comes into this class can add fractions. All you got to do is practice it. Okay. It's not a difficult skill, but you do have to practice it. Yeah. And the reason you want to be able to add fractions is because pretty soon in your pre-calculus course, you're going to have to be able to add fractions with symbols. And if you can't add them with numbers, and if you're not used to the operations, finding common denominators and stuff like that, you're going to be lost when you get there. So we want to cover that. Okay. So make sure you do a good job of that. Now, composite functions, I gave you an example. Again, that video ended up not having any audio. Yeah. And I hope this afternoon to get those videos at least summarized. So you got some words to go with them in transcripts and so forth. I managed to get calculus, pre-calculus done yesterday, but that's all I had time to do. I'll have h of x. G of x. Let's let g of x be our old friend 1 over x squared. And h of x equals 2 to the x. Now, if you remember about function notation, and I think I gave you a really nice explanation of function notation last Thursday when there was no video, no audio. So I'm going to try to repeat that, okay? Or at least try to give you, I don't know if I can do as well as that one, because I really like that explanation, but we'll see if I can do it. Okay, so anyhow, here's your g of x, here's your h of x. If you recall from, I think it was last Thursday, you're replacing x by h of x. So wherever you see an x up here, you have to replace it. It's going to become h of x, right? So that means quantity squared. That makes sense? I hope so. If not, look at the video that's hopefully going to be posted later this afternoon. And OpenMath is going to tell you the same thing, but in different words. You're going to talk about inputs and outputs, as I did, and as I would right now if I had a little more time. It's 1 over h of x squared. If x is replaced by h of x, then you got to replace x by h of x, right? Here's the rule for g of x. Whatever replaces x has to replace this x too. And then h of x is 2 to the x. So you can replace h of x with the formula for h of x. And that is one over 2 to the 2x by the rules for exponents. Remember how you do a power of a power. Okay. What's 2 squared cubed? 2 squared is 3 groups of 2 2's. Right? Gives you 6 2's. Remember, you always come back to that idea when you think of laws of exponents. And if you lost track of it since we went over it earlier, I think we went over it earlier. And how you got to know it. Okay, so that's 1 over 2 to the 2x. And you could also write that as 2 to the negative 2x. And if you graph this, it would be a bell-shaped curve. That's just a compound normal curve. It had statistics, you've done a lot with it. It's just a composite. It would be if g of x was negative x squared, then as I know, h of I'm not even going to say it. It's 2 to the negative x squared. Okay, which would be your inside function would be negative x squared, and your outside function would be 2 to the x. Okay, so this would be your outside function instead of your inside function, and the inside function would be negative x squared. You don't have to know that right. All right, well, you have something to look forward to. And pay careful attention to these assignments.